welcome back to everyone. So obviously Amy and I have been working through trying to understand what the nature of this oil that we've been finding on site on this new loss is. And part of that is that the color is very different and various bits. So listen back to previous, we won't repeat it. But what we've been finding is that Amy's basically, and Paul on the call are at Socotec have gone through and done a lot of really, really detailed and really interesting analysis and kind of interpretation. And so with that in mind, I think it'd be really useful for us to record the discussion as that information comes back, and equally kind of talk through what it means for us on site and what the next steps are, etc. So Amy and Paul, I think it's over to you guys.
Okay, now this is the field drain sample that Adrian and I were looking at. And the chromatogram looks like this. And on the chromatogram, you can see that it's slightly evaporated kerosene because there's some loss at the early end. But this particular sample was dark. And then we looked at the 57 ions, and from that you can see that there are peaks from C8 to C16, which is in line with kerosene. And as Adrian and I suspected, it is mainly kerosene, right?
Yeah, it seems to be, as you kind of described it, as it's chemically kerosene. But obviously the color is not that of what you would expect.
Yeah, and from talking to the laboratory as well, it would only take a small amount of bitumen to turn the kerosene into a licorice color, which is what we observed when we did the first vlog.
Yeah. And I think that licorice color really describes it really well, because that's exactly the color it is.
Yeah. And like we saw, Adrian, it didn't have the consistency of tar either, did it?
Nope, not at all. No, it's very, very mobile. So it's, completely different to that. And we were on site actually this morning again, and I'll talk about, it's interesting what you're saying about the slightly aged element to the oil. So got a bit of an insight on that. Don't know whether you want to talk about it now or whether we talk about it.
Go for it.
Okay, well, so we started to lift up the resin and drive essentially to the front of the property beneath where we think the oil leak occurred, because we've broken the oil line into sections, and it's a 1-inch, 25 mil metal red oxide pipe. Essentially, that's what the oil line is. And so it takes some twists and turns underneath the ground. And so as a result, it has what are described by Offtech as mechanical joints. So really it should be pressure tested, preferably every year, but at least every 5 years. And I don't think it's ever been pressure tested, but should be. And that's a should rather than a must, but it's still, it's good advice. So what we found today was that as we exposed it, literally the oil line is so corroded that it's almost like it was described as more like a cheese grater than a pipe on site. So it's literally peppered with holes. So it's really, really surprising actually in that respect. And so I'm surprised. So I think it's highly likely that it was leaking for a while, and then has gradually got worse. But we've probably got a section of at least a meter long now that is just perforated with little pinholes, some as big as sort of 2 or 3 mil in diameter. So surprise that it doesn't hold pressure under a pressure test. So that aged aspect is probably quite relevant, because I think that won't have happened overnight, and so it'll have likely been losing oil for a period of time gradually, and then eventually catastrophic loss.
So that pipe just wasn't maintained.
Well, it wasn't. I guess you would have, if you'd been doing regular pressure tests, you would have got an early indication of a problem. Whereas if it's all below ground, no inspection points for the joints or anything like that. So you have no ability to inspect it. And so if you put a metal pipe in the ground, it's going to rust, isn't it? eventually. So it it wasn't in a conduit or anything like that. It was just literally lying in the ground. And I think this particular area where it was quite wet, and so as a result, probably quite corrosive in that regard. And equally, I guess the other thing that was very visible at that point when we opened up the ground is that the bitumen hard surface beneath the resin was very, very shiny, almost like it'd been, like new hot new hot bitumen surface that had been put down. I think that's obviously a function of the kerosene has really softened it up. But it was like malleable, almost like Play-Doh. It was so
Wow,
soft.
that's interesting.
So not like it's 25 years old, so it should be quite hard, but actually
Yeah.
soft to you just break it up in your fingers, like crumble it. Interesting.
Yeah, definitely. Now let Paul talk on part 2, which is where we analyze the bitumen primer sample.
Yep. So we've obviously looked at your kerosene, and it's essentially obviously kerosene, little bit of evaporation, but nothing particularly too exciting. On the distribution of the hydrocarbons, we can see on the original chromatogram, and C10 and C11 was a bit higher than I would expect. This is where possibly it's related to the bitumen. So when we looked at the bitumen, we obviously extracted it and ran it on the GCMS. And the thing that shows initially on the chromatogram we can see is a C8 to a C12 paraffinic solvent. Also, C9 and C10 are quite high in that, but predominantly a paraffinic solvent. When we blow the baseline up, then we can start to see the heavier hydrocarbons. So you can see on the right of the chromatogram, we have the hump with each alkane showing. Now, it's not responding very much. And the reason is because it's extremely non-volatile. So if you've got a very heavy tar, it will be very viscous and almost solid-like. Then you will literally have no response on the GCMS. This is where TPH analysis in the environment becomes problematic, because classical TPH tends to be around about C10 to about C40-ish. So that covers your main things like your kerosenes, your diesels, your mineral oils. But when it comes to heavy tars, they can be highly contaminated in the environment, and you will not see them on a classic GC-TPH analysis. Right. So it's something to bear in mind when you're working with this type of material. Yeah. So you don't need, as I say, much of this material within the kerosene to cause it to go a dark colour. The reason why the bitumen primer, did you say, Adrian, that it was quite thin? It was quite
So I guess I guess we it's the bitumen primer that we use when we're doing installing vapor membranes, and we're printing seals and stuff. So it's definitely not as thick as you would have next to like a bitumen surface. What it tends to get described as tarmac, but isn't. And so that's obviously much heavier. This is much thinner than that, and so much more odorous and volatile in that regard. So, but it just happened to be a sample that we had of a similar product in the yard, essentially.
Yeah. So the C8C12 paraffinic solvent is literally thinning it down, and it's the heavy bitumen tar material which is probably doing all the work. That obviously you can't paint a really tarry bitumen on, so it's diluted in the paraffinic solvent. The idea is the paraffinic solvent over time will then evaporate off, and cause the tar to be retained. And it will then go thicker, more viscous, and then obviously produce the seal.
Yes.
Yeah. Now, the difficult thing is to prove that the bitumen is present within the kerosene, and that's what we've worked on for the last few days. It makes it very difficult. On this slide, we can see on the bitumen, we've pulled out particular ions for hopanes and steranes. So these are cyclic biomarkers that are in heavy fuels, heavy oils. They don't degrade and they can be used as a fingerprint. And we often use those for confirming that something is a mineral oil or a heavy bitumen. But you can also use it to match it to sources because they don't break down in the environment. So having those predominantly hopanes, the steranes aren't really there, but the hopanes are there. So we can use that as a fingerprint to actually see whether we can actually see that material. Now, when we looked at the original sample, then you couldn't see any of the heavier bitumen materials and you couldn't see these hopanes or steranes.
No.
So essentially it was kerosene. However, because it was a dark colour, then that's when the thoughts of, is there evidence of the bitumen present within the sample? Yeah. So that's what we went off and investigated. So part 3. Oh, there we go. So
Which is really interesting. It's very good work.
Yeah, so we took the original suspect kerosene sample and we evaporated off as much as possible the kerosene portion of it. So it was put onto a heat block and then nitrogen was passed over it for pretty much overnight. The kerosene eventually evaporated away and we were left with a black sticky residue. Now, some of that residue you might expect to be left over from the kerosene, but obviously with our GCMS we can actually identify exactly what that material is. So on these, I think we've got the 57 traces. So the top one is the bitumen sample. So you can see the hydrocarbons are much more to the left, therefore they're slightly earlier. As we've already said, it's C8C12. So around about 8 minutes, just under 8 minutes will be like the C12. So that's the end of that. Then we've got the unknown kerosene in the middle. And again, you can see the hydrocarbon distribution. It starts a little bit later, but ends much later because it will go on to 16. Yeah. Now, the C11 and C12 on that blue trace, around about 6 minutes and 7 minutes, those stand out a bit more. Now, if you look at the top spectra, where you've got the hydrocarbons from the paraffinic solvent to the bitumen, C10 and C11's higher, but 11 and 12 could be contributing to the 10 and 11 could be contributing to the 10 and 11 that's higher in the kerosene. So that's an indication that material's there. C9 probably would evaporate away. So that would be the first one to go in the environment just by naturally. Okay. And then the second sample, the unknown sample, the kerosene is evaporated to a residue, and then that residue is analysed. And the hydrocarbon distribution we can see there is a lot heavier. That to me is more like diesel. Right. And it's probably always present in your kerosene because kerosene is made by the fractionation of crude oil. Then a fractionation is never perfect. And you'll always get either lighter or heavier fuels within that makeup. So by evaporating off the kerosene, we've actually shown a very slight, tiny amount of diesel type hydrocarbons, which again are always there. It's just that you'll never see them unless you do this experiment.
Yeah, no, it's interesting.
So this is looking at the really heavy bitumen side of it, the really heavy tar side of it. So again, the top one, we've blown the baseline up so we can see what happens. So the top one is your bitumen sample. So you've got the really early paraffinic solvent at the front, but then you can see these hydrocarbons, the very heavy material on the right-hand side. On the middle one, which is your normal kerosene that we recovered, there's no evidence of that material at all present. But by evaporating it down and concentrating that tar-like material, you can just start to see on that the bottom trace, those hydrocarbons are starting to come through. And when we look at I don't think we've got a trace on this. When we look at the hopanes and stearanes, we can again start to see those 3 hopanes at the same retention time coming through. So by evaporating off the kerosene, we have proven that the tar part of the bitumen sample is starting to be seen within your kerosene sample, and therefore is probably the source of the discoloration.
Yeah.
So that's quite interesting, Adrian, isn't it? Because when we had our first vlog, that's kind of what we said.
Yeah, no, that is. So it is quite nice to be, or close to correct anyway, or as close as we can.
I mean, one thing as well, Adrian, which, with kerosene spills and like bitumen and blacktop is the solubility. So when we were looking at coal tar analysis, I had different tarmacs, different blacktop, and she'll call it tarmac, from different ages. So sort of like the 1970s, pre-1970s or the 1960s, it was more coal tar based. And then in sort of the 80s, 90s, we moved over to non-coal tar, but hadn't been perfected. And then the new stuff that came out. So we did an experiment where we took 3 different ages of blacktop from around my house, actually. And we did solubility tests in solvent. So we picked we picked a DCM, so a solvent that we'd use in the laboratory, but then we also picked petrol, and then we picked diesel, because petrol and diesel obviously are leaked into the environment. Coal tar, so the good old-fashioned coal tar blacktop, was resistant to both petrol and diesel, didn't do anything.
Right.
The 1980s, we aged this by, I went round to different housing estates that were built. So my houses were built in the 60s, and then I went to a 1980s housing estate, and then I went to a road that had just been dug up, and then tarmac had been put on. So I took a little bit of it before it hit.
So you went round the houses.
Yeah, nicking it all.
Brilliant.
Nice.
So the good old fashioned one, I say that was resistant to petrol and diesel. Now the 1980s one, that was the petrol had started, as soon as you put it in, starts to dissolve it.
Right.
But the diesel wasn't too bad. It did start to dissolve it, but it took a lot longer to dissolve. The new stuff that was being put around my area, petrol and diesel, as soon as you put it in, instantly just dissolved. So I would have said your kerosene will be acting probably in the middle of petrol and diesel. It's a bit more solventy and a bit more powerful than the diesel will be, but not as powerful as the petrol will be. So if you're having spills of kerosene, especially on new sort of blacktops or bitumens that are used for like lining and waterproofing and things like that, then you will get some dissolving, which obviously is probably what you've seen here, which is the discoloration of the kerosene. But then I expect on an insurance side, you've got to think to yourself, what effect has that kerosene now had on any membranes, any blacktops, all this lot? So it's just something to bear in mind,
It is, yeah. And I think probably this one probably falls into the 80s, 90s piece. So it's probably not as bad as current. We've definitely seen fuel spills onto, as you say, new bitumen or hardtop surfaces, driveways, and they pretty much disintegrate instantly. So if you've got a leaky car, even, it just has such an impact on it. So we definitely do that, and I think with this one we're worried about the bitumen, because it's got basements and it's got a pool and various things. We're worried that, that might be that the waterproofing, etc., associated with that could be at risk. And I guess that was initially when we were kind of working through scenarios, why is it turned black? Our kind of initial one was we knew about the bitumen that was used as waterproofing on the outside of the basement walls and the subground walls. So we were like, oh, that's not a good sign. But so we're now working on the more positive thinking that hopefully it's just limited to the driveway area, and it's just the driveway that's resulted in the discoloration. But we are mindful that we are going to have to prove one way or the other whether the building and the associated waterproofing has been impacted. So yeah, we'll need to look at that before we can sign off, essentially.
Yeah, yeah.
It's interesting, Adrian, that in a way the science has kind of verified your initial thoughts and what you saw on site.
Yeah, and I think I guess it highlights the importance of experience and that knowledge, but it's that knowledge that's just in here and in our heads, essentially.
Yeah.
And then you go away and you take the appropriate tests and you do the appropriate, investigations to prove that theory one way or the other. And I guess that's one of the challenges with remote working and everything else, is that how do we as scientists essentially train the people of the future if they're not in the room? Because these things they're not, by this time next week, we'll have moved on and we'll be on to the next project or whatever. And so we won't be talking about it anymore. And so how do you, quite a lot of my learning as a consultant through the years has been just being in the room with really clever people, and listening to the conversations and perhaps if I'm lucky, getting involved in some of the conversations, and then obviously later on leading some of the conversations, but trying to get, junior people involved in those so that they can, we're not necessarily expecting them to know where they're at, but if they're in the room, then they can take that on board, basically.
Yeah. And also communication as well. So there's got to be the communication between the consultants in the laboratory. A normal analysis, if you had just said that, saying what's in this, we would have come back and said kerosene. End of story, because that's what it was. But it's only by the communication between you and us and the story behind it, the theory behind it, then that's when we can say, oh, okay, then we can design an experiment to see what are the things that we wouldn't have seen there, which we would never have normally done. This is not standard analysis. And we've never looked at this really heavy fraction of a kerosene before. We've never done that because we've never had to. No one's asked us to. It's never been part of a story that we go, oh, right, this is how we can see. How do you detect such a heavy material in something like kerosene? So, if we don't have the story behind what the consultants are trying to figure out or what's going out on site, we will not be able to then try to devise something to try to answer the questions. So it's got to be that communication, and that's what doesn't happen too often.
No, I think it becomes quite often it's very easy in today's world to just end up in some sort of transactional relationship, really, whereas actually, the value of being able to have these conversations and kind of work through the problem together is, works both ways, in that obviously the analysis is more expensive, but it actually gets us as the consultant to where we need to be, as opposed to, working on an assumption, which basically going, well, the lab results are rubbish because obviously this isn't kerosene because it's black, so you kind of go, so it's one of those things, as opposed to getting up in that space, you kind of, it's more collaborative, which is where we need to be.
Yeah. Also, it's great for us chemists as well, because we get to understand what's happening on site, and then we start delving in deeper to gain our understanding of it as well. And like you say, it's always good to collaborate. So the lab and the site side can kind of mesh together.
Yeah, absolutely. And I think
that improves things.
Yeah, and I would just say the next phase of this is we've obviously got a little bit of a mixed challenge around waste classification as well now. So you've got, a resin surface on the drive, which has been recently put down, and that tends to get classified as hazardous waste. You've got the bitumen surface, which likely would drive a hazardous rating as well. And then you've got a kerosene contaminated soils beneath, which would typically be a non-haz soil contamination, classification. So we've got this kind of situation, but because particularly in the main source area, we've probably got quite much higher levels of bitumen proportion within the kerosene contaminated soils. It's likely that that's going to need to be classified as hazardous. But I think, Amy, I mentioned it to you earlier today that we're probably going to need to do some more kind of interpretive analysis to try and work out, because the benefit to us and to our clients obviously is if we can properly characterize the waste and segregate that as best we can, then we can essentially send, even if the waste costs exactly the same, the difference between some waste going to landfill and some waste being able to go for recycling, obviously it's more sustainable and better for the environment if it doesn't go to landfill. So that's kind of the next bit that we need. The project leads need to prioritize, because we're going to be generating lots of waste, and we're trying to segregate it on site at the minute. But equally, we're going to need to kind of line up all of these routes for disposal or recycling that we're going to need to have in place. So yeah, that's probably the next thing that we're going to need to send some samples across to kind of have a look at that, and then we could probably be interested to then maybe have another catch up on this to talk about what we found and how that ended up playing out in a couple of weeks.
That'll be really interesting, because it's gone right from that one black looking sample to then doing the higher end testing and then to waste disposal. It's quite a good life cycle, really.
And I think it's another good example of one of the reasons. So how did the oil end up in the surface water drainage? Some might have asked. So the answer to that is that when some drainage was put through into an old manhole at some point, the pipe, the 110 mil pipe, was just bashed through. They just kind of went, well, surface water doesn't really matter. Bashed it through the wall and just kind of let it kind of sit there. And the issue being that when the oil was then present around the outside of that chamber, it poured into the chamber and then was able to find its way into the surface water pipework and off and move around basically along that route. Equally, what we found is that because the pipe wasn't properly sealed in the chamber, water during high rainfall events, which we're seeing more and more of because of climate change, is essentially that more water was getting into the sub drive environment, resulting in actually that's probably what raised the kerosene up and pushed it up against the top of the bitumen, or the hard top, because the water level was rising, because the water was, as that chamber filled up with water and was pouring out, it couldn't pour out fast enough because of all of the rainfall events, the intensity. And so actually it was pouring out around the pipe as well into the subsoil environment, and then spreading the oil all around the place, making things worse. And then resulting in oil then being able to float back into the chamber and then off into so it's kind of a cycle of doom, really, in terms for the environment. So to all those people out there installing drainage pipes, please make sure you do a proper seal when it puts in. It looks nicer, and when it all goes to pot, it does protect the environment.
Yeah, but the thing that struck me the most is when we were actually looking at the samples, and you're going like that with the sample, and you're like, it's actually a lot. It's not as bad as it looks. It's probably, it looks probably 10 times worse. And then when we analyzed it, you were actually right. This is quite
Yeah. And again, it looked
So-
the exact same today because we'd exposed, about this width of area beneath the drive over the top of the oil line. There's water in there, and it just looked like just black oil all over the top, and it just looked absolutely horrendous. But there was actually not that much oil there, and so it looked more like engine oil on top, when you look at it. But it was
Yeah.
once you, just kind of put an absorbent in there and just mopped up very tiny amount of oil, it was fine. So it, again, yeah, looked, and I guess it highlights the fact that a small amount of oil on a surface water, does go a long way. It's one of those things that can look a lot worse than it is, but still pretty bad, to be fair.
Yeah. So I guess the next stage is the waste analysis and then watch the space.
Yep, and that's it. And so we're ongoing with mitigation to obviously try and make sure that we're, if the house hasn't already been adversely impacted, that it doesn't get impacted while works are ongoing. So we're doing emergency works to protect that, and equally, while we kind of work through where we're at. So it's busy couple of weeks ahead, I think.